Hello, linear algebra student. This video is for chapter 2.2, part 1. We're going into looking at something called the inverse of a matrix. In 2.1, we say matrix is an object that we can use it for calculation. We can add and we can subtract. So there is something called like the inverse of a matrix. What is the purpose of it? If I can multiply two matrix, right? A times B equal to, say, for example, C. Can I divide matrix together? So can I say divided by A divided by A like this? So B is equal to C over B, C over A, right? Can I do that? So there is no division in matrices. We only have multiplication. So to do matrices, basically you have to introduce something called an inverse. Kind of like so there's no such things, okay? But the purpose is getting the inverse is so that we can do similar to division. Because if I say 2 times 5 equal to 10, if I want to divide it by 2 on both sides, right? So it's the same as multiply by 1/2, right? Why? Because 1/2 would cancel the 2 is the inverse of 2. So it become 1, right? So you can see that multiplying the inverse is kind of the same as dividing. So in matrix, we'll define another entity called A inverse. So that and then the notation of A inverse is A to the power -1. Kind of like A 5 to the power -1 is 1/5 like that. So if I have an A matrix and I multiply this inverse A to the power -1, which is the A inverse, this is just a notation. It actually just means the inverse of A. Then it would become the identity matrix. So, and also this is the A inverse has a special properties where if you multiply the A inverse to the left or right of A, it's still the identity matrix. So this is the case when the commutative properties hold. Now, not all matrix has inverse. Just like in numbers, 0 doesn't have an inverse, right? 1 over 0 is undefined. So there are some matrix that has no inverse. And if it has an inverse, it's called invertible. And if it doesn't have an inverse, it's called singular. So an invertible matrix is non-singular. So these are the terms. Invertible is just non-singular. Singular means non-invertible. So just two different terms to represent matrix that has that are invertible. And obviously, the 0 matrix has no inverse, right? 0, 0, 0, 0. What does it multiply? That's equal to identity. Identity is 1, 0, 0, 1, right? For 2 by 2. It's not possible to do that. So this is singular, non-invertible. But there are some matrix that are invertible. So how do I find a matrix? It turns out that there is a formula for inverse of a 2 by 2 matrix. And also there's a way to find if it is invertible. So how do I find it? If it is invertible, we say the 2 by 2 matrix is ABCD horizontally. AB is the first row, CD is the second row. Then I can do multiply the diagonal AD minus the backward diagonal BC. If it is not 0, then it's invertible. Okay, if it is not 0. So A inverse will be 1 over AD minus BC, and then A inverse, the inverse would be switching A and D. The main diagonal, you have AD originally, you switch to DA, and then the non-diagonal, you switch the sign. It turns out that this is the A inverse for a 2 by 2 matrix. So yeah, so before you do the A inverse, check if AD minus BC is 0, because if it's 0, then obviously you cannot do 1 over this. This value is undefined, so there will be no inverse. It's singular. So this quantity actually has a name. It's called the determinant, because you can use it to determine if the inverse is invertible. And in chapter 2.3, the next chapter, we will talk about the determinant in more detail. Yeah, and this relationship is like both way. It's if and only if. If A is invertible, then AD minus BC is not zero. If AD minus BC is not zero, then A is invertible. So let's practice doing it. So how do you know it is? We can we can talk about this later. There's a way where you can actually discover how to find the inverse. But so far, if you multiply A and A inverse, you can, try by multiplying out. It is equal to the identity matrix. So let's say I have an example 1. My matrix A is -2, 1, 3, and 4. I want to find the A inverse, find the inverse of A. So I need to find the determinant AD minus BC. So be AD -2 times 4 minus 1 times 3. So that would be -8 minus 3 is -11. It's not 0, so it has inverse, right? Inverse exists. And I'm going to find the inverse. The inverse is 1 over this determinant, -11, and then a matrix, because an inverse, of course, is a matrix. So the main diagonal switch, the non-diagonal, just change sign. And there, so if you want to, you can multiply it in. You will say -4 over 11, -1 over 11, -3 over, no, this is positive because it's negative here. So it'll be 3 over 11 and 2 over 11. And this is the inverse of A. We can check, okay, just to make sure it is -2, 1, 3, 4. If I'm going to multiply -4 over 11, 1 over 11, 3 over 11, 2 over 11, let's try. Row times column, 2 times 4 is 8. 8 plus 3 is 11 over 11. This times this, row -2 times 1, that's -2. 1 times 2 is 2, so it's 0. Row times column, -12 plus 12, 0. 3 times 1 is 3. 2 times 6 is 8. 8 is 11. So there, this is the identity matrix 1, 0, 0, 1. So this is the matrix where when you multiply by A with A, it becomes the identities. And you know, for identity matrix, if you multiply with any matrix, it would be just itself. So we have two matrices A and B. We want to check if it is invertible. Let's check A. Oh, determinant of A. AD, 0 times 1, minus 0 times 1. Of course, it's 0, 0, so no inverse. B, determinant of B. AD is -1 times 1, minus, remember it's minus, A times C. C times B times C, 4 times 1. So this diagonal minus this diagonal. -1 minus 4. -5 is not 0, so inverse exists. So there is a B inverse, but there's no A inverse. Inverse and AX equal to B. So what can we use inverse for? Well, it can be used to solve a AX equal to B matrix equation. So this connect back to a long time ago when we rewrite a matrix equation as a representation of vector equation, right? So, well, actually, if I know more about matrix, now I can do that. I can say A, if AX is equal to B and A is invertible, then I can multiply B on both sides. I'll multiply A inverse on both sides. And remember, multiply in the front, right? because matrix multiplication is position oriented. So A inverse times A is 1. Oh, is I. I times X is equal to A inverse B. But what is X? X is the solution, right? So that is the solution, the weight of the vector equation. So I'm going to just do it now. So if I can find the A inverse and multiply by B, I will have the solution. So step 1, find determinant A, which is -1 times 1 minus 4 times 1. This main diagonal minus the other diagonal. So it'll be -5, right? And so so A inverse would become 1 over -5, and then the switch 1 and -1, switch A and D, and then switch sign for those. So this is the inverse. And my answer X would be A inverse B. -1/5, 1 -4, -1 -1 times B. B was 3, 2. So use matrix multiplication, horizontal row times column. 3 minus 8, so it's not -5. -3 minus 2, so it's also -5. So that is equal to 1. Multiply the scalar in is 1, 1. So the answer is 1, 1. So this is one way without doing row operation or augmented matrix to solve for x. Use inverse. You can see that it is only for 2 by 2 matrix, right? So what happen if it is not? So we will talk about how to find the inverse of a 3 by 3. So you can use inverse to solve equation. That is the process. The process is find determinant of A, find the A inverse, then X is A inverse B. A inverse B. Because you multiply A inverse on both sides. So you go to A inverse times B. This is the solution. Okay. So let's see if I can use it to solve systems also. So remember we will write the coefficient matrix 3, -2, 5, -3, right? Times my xy or x1, x2 equal to 1, 5. So this would be in matrix form, matrix equation form, and we say x is equal to A inverse B, if you can write it this way. So what is A inverse? Step 1, determinant of A is equal to 3 times -3 minus the -2 times 5. So that would be -9 plus 10 equal to 1. Okay, so A inverse would be 1 over 1. Main diagonal, switch position. The other diagonal, switch sign. Oh, plus +2 and -5, right? So that's A inverse. X is equal to A inverse B would equal to -3, 2, -5, 3 times my B, which is 1, 5. So that would be row times column, -3 plus 10, so that is 7. Rows times column, -5 plus 15, so that's 10. So my xy is, I should not say x, right? I should say xy. Xy equal to 7, 10, so you can say x equal to 7, y equal to 10 is the answer. So you can write a system of equation in terms of the coefficient matrix, the unknown vector, and then the other vector. So instead of, thinking of vector equation of x